Today we have a new concept, new topic. The name is recursion. Recursion is one of the hardest unit, one of the difficult unit in the APCS data structure class. So if you can understand today's lecture, you're gonna be ready for the next year's recursion unit. Recursive method means you are going to call the method inside of the method. So method name is a recursive method. Then you are going to call the recursive method by passing different argument. So if I pass the argument n at here, then inside of the method, you are going to call the recursive method again with like a n-1 or n+1 or n times 2 or whatever, but different n values. Definitely, by checking this argument in the basic case, in the statement, if you have to stop, you're going to stop. So we call this one as a stop case or base case. Recursive method must have stop case. It's like an endless while loop. When we had endless while loop with true, we had some stop case. One good thing of this recursive method, you don't have to write alone. Usually recursive method is much shorter than the explicit method. So let's think about geometric sequence here. So let's approach it with the method. This is a geometric sequence. How many of you know geometric sequence? Can you raise your hand? Only one person? Two. This time, okay. Thank you. Geometric sequence starts from the first term. To get the next term, it is multiplying common ratio, right? We call this one as a common ratio because we always multiply same, so the common, to get the next term. So when you get the nth term of the geometric sequence, you start from the first term, then how many times you multiplied common ratio. If you multiply common ratio one time, you are going to get second term. If you multiply common ratio 2 times, you are going to get third term. So one less time you are going to multiply. So common ratio 2 and minus 1. We call this as explicit formula. Oh, A. There was no space for A. We are going to think about this one as a recursive. So explicit formula is starting from the beginning, but recursive is starting from the current. Let's think about this is nth term. To get nth term, you need to look at only one previous. That is n-1 term. You are going to get nth term starting from the one previous by multiplying common ratio 1 time. So I can write this one, A sub n, so nth term is A sub n-1 times common ratio r. Or you can also write r times A sub n-1. Either way. But only one thing, if you have this rule, it will go to n-1 term. N-1 term will look at n-2. N-2 will look at n-3, n-4, n-5, n-6, n-7. It's error. So it needs to give stop case. Stop is the first term for the recursive formula. So you must give first term is something. So this is the stop case. I'm going to rewrite this one as method. I'm going to say A is the method name. So A passing n. This is my method. Instead of this method, I'm going to have two cases. First, if n is 1, this one means n is 1. So if n is 1, I'm going to return 2. Other case is called common ratio, and this case common ratio is 2. So I'm going to just say return 2 times a by passing n minus 1. This is else case. If we name it, instead of a, like a power of 2, then passing integer n, I said return, so it is a return type method. So return int. Then this is the base case. Start case, when n is 1, return 2. Then else case, common ratio 2 times, the same method name, power of 2, then passing, and minus 1. This is how to think about recursive method, starting from the current position. Then this is how to drive your method implementing. Any question here?